Remember the Alamo. It's in San Antonio. All right. So lesson 8, guys, on the Pythagorean Theorem and irrational numbers. We're going to cover both of those today. Pythagorean Theorem a little later, but to solve a couple of these questions, we're going to have to discuss early in this unit. To be an irrational number, Brooklyn, you ready to listen now? To be an irrational number, it's a number that cannot be written as a fraction or a decimal that repeats or stops. Okay, so an irrational number, pi is a common irrational number. You can't write pi as a number that repeats or a number that stops. I mean, it goes on forever, right? We are estimating when we use 3.14. Square root of 4, for instance. What is the square root of 4? 2, right? Because 2 times 2 is 4. That is rational. But the square root of 3, do you know what the square root of 3 is? No. So if you type in the square root of 3, the reason you don't know that is because it is irrational. Okay, now it goes on forever. Doesn't repeat, doesn't stop. So that would be an example of irrational number. The calculator just goes so many digits. Most of them are 8. Scientific ones are usually 10, but usually rounds the last digit. So we're going to look at lesson 4 here to start and talk about square roots. Remember, those are irrational. Where they would go on a number line if we were to plot those. So the first question here, it says, what is this diagonal? Now, is the diagonal usually going to be the longest or the shortest side? The diagonal should be the longest side. Anybody that's ever done any construction, to see if something is square or built anything, you use the Pythagorean theorem all the time. Because in order to make a right angle, that's what being a square means. This would have to be a right triangle. Okay, so what we're going to do is figure out the length of this diagonal using something called the Pythagorean theorem, named after a Greek philosopher named Pythagoras, who was the first one to come up with this. He said if you take both the small sides, let's call it A and B, those would be the small sides called the legs of the triangle. There is a equation that we can use to get the longest side. We'll call it C, which is called the what of the triangle again? Longest side?
Torso.
The hypotenuse of the triangle. Okay? So A and B are legs. I better write that down. Longest side is called the hypotenuse. So here's the equation. Here's the Pythagorean theorem.
How do you spell that? Hypotenuse. It's at the front.
Hypotenuse is? Pythagorean theorem or hypotenuse?
Hypotenuse.
Oh. I did HYPOTENUSE.
I'm just going to go with my version.
All right, so again, this is a Pythagorean theorem. So what is the distance of A? 1. What is the distance of B? 1. C? We don't know. That's what we're trying to find, right? Now, we do know that the hypotenuse, the diagonal, should be the longest side. So I'm going to square both of these. So I'm just going to plug it into this equation. A squared plus B squared equals C squared. 1 squared plus 1 squared will equal whatever I'm looking for squared. So what is 1 squared plus 1 squared?
1. 2.
It's 1 plus 1, right? 2. Now, I don't want to know what C squared is. I want to know what C is. So just like when we've done equations, when you had adding, you subtracted. When you did multiplying, you divided. You always did the opposite, right? So how do you think I get rid of that? What is the opposite of squaring something? Square root.
Let's go.
Square root. So your answer, I'm going to square root both sides, would be C equals the square root of 2. Now, in your assignments, it'll say give the exact answer. That's what it's referring to. That is exact. Okay, now if you type it in a calculator, what is the square root of 2? Why don't you try your iPads, make sure you can find the square root button. Type in the square root of 2. And let's round to the nearest. Let me see what the directions usually ask. Nearest 10th. Nearest 10th. Looks like a little check mark.
There's a bunch.
All right, let me see.
1.414213562371.
All right, so what do these different buttons mean? So this is a square root. This is one you're going to use. This is a cubed root. Like the cube root of 8, for instance, is 2. 2 times 2 times 2 is 8. You're not going to use that one for me this year anyway. And this one you can do different roots, like 4th root, 5th root, so on. So this is the one you want right here.
What's X exclamation? What's the X and exclamation?
That's factorial. So if I type in 5 factorial, that's going to be the same as 5 times 4 times 3 times 2 times 1. Instead of typing that in, if I type this in, it automatically does 5 times 4 times 3 times 2 times 1. Every number behind it.
Sin, cos, and tan are all triangle related, right?
Yeah. Sine, cosine, tangent. These are the opposite. This is to go from degrees to radians. Exponential functions.
If you click E while it's at 0, you get negative infinity.
I think we should just mess around with the calculator on the line.
We just did.
Never mind.
All right, guys, play with your calculator today. No, all right. So do we have this rounded to the nearest tenth?
1.4.
Do you agree with that? All right. Do you agree with the statement that we made before that it would be bigger than 1? Yeah, well, our answer proves that it's bigger than 1. So if ever asked for exact, I want this. Round to nearest tenth, obviously this one. Leave the calculators out, you will be needing them. So you just answered 1 and 2 again, they were on the next page. Doing the same thing. All right, I want you to try this one. Don't say it out loud, but see if you can get the exact and a decimal approximation rounded nearest tenth for that one. Yes.
Yeah, because it's a 6 after that.
3.16? Okay.
Okay, I got it.
Questions on that?
Yeah.
Yes.
When you write, like, on the top one, do you put a square? Not down, in the box. Down.
No.
Okay.
Oh, here?
Uh-huh.
No, because you square root it to get C. Square root this to get here. Yes.
I got something completely different.
Okay, what'd you get for your sides? Did you get 1 and 3?
You find the square root, so you would hit the 3 and then the square root button on your calculator.
You add first and then do the square root at the end.
Oh.
You can't do it individually.
So you do 1 times 1 plus 3.
Correct.
Okay.
Imagine this being in parentheses then. Do that before you take the square root.
Wait, so is the base always 8?
Yeah.
No, it does. I mean, it doesn't matter.
Oh, okay.
You're adding them anyway.
Oh, right.
It doesn't matter which one. As long as the longest side though has to be C. If you put these other ones C's, it's not going to work. All right. Next page.
He's wrong.
Diego said he thinks that the square root of 3 is about 2.5.
Yes, 2.5.
Use the square to explain why that is not a good approximation. Now, when you square something, You know, let's say you have 2 squared, right? You would end up with 4 squares, 2 times 2. If you go 3 by 3, of course, you would have 9 squares. Okay, and that's why it's called squared. You have the same going each direction. So looking at this one, it says the square root of 3 is about 2.5. It says use a square to explain why 2.5 is not a very good approximation for square root of 3. Find a point on a number line that is closer to square root of 3 and draw a new square. Well, let's just talk about some common ones. Normally, if we had more time, I would ask you to memorize 20 of them.
Oh no.
Yeah, I'm grateful we don't have more time.
Square root of 1 is 1.
Yeah, so think of it this way. 1 squared is 1. 2 squared is 4. 3 is 9. 3 times 3 is 9. 16 is 4. 5, 6, 7, 8. Now let's see if we can keep going. See how many you can get. See if you can get to 20. 9 squared, 81. 10 squared,
100.
11 squared,
132.
121. 12 squared,
144.
144. 13 squared,
Wait, let me check. Can you move the paper up a little bit?
169.
just square. Just 1 squared, 2 squared, 3 squared. You can get them.
169.
169, and then 14 squared is 196. 15 squared is 225.
How do you have that memorized?
You use them enough, you just get it.
256 is 16.
256, 289, maybe?
Yeah,
289.
289 for 7.
18. This 3, 20, 21. 19.
361.
Yeah, so once you do a lot of them, you get them memorized.
Math went from
Usually you can get to about 12. Most people can get to 12, and then once they get 13 times 13,
20 is 400.
20 squared is 400. All right, so thinking about this. So the square root of 4 is 2, right?
What's half that? Square root would be
What's half of what?
4.
What are you asking? Half of 4?
2.
Yeah, but that doesn't work for all of them. What's half of 9?
4.
Not 3. Okay, so be careful what rules you're applying here. The square root of 3, why does it make sense that it's not 2.5? Well, the square root of 4 is 2. So if I go lower than 4, don't you think this would be less than 2? Yeah, so once you have some of these common one memorized, things like that will pop into your head of why it doesn't work. So let's just plot a couple here. Let's plot where we think square root of 3 should go. So we know square root of 4 would be 2. We know the square root of 1 is 1. So where do we think, and we just did the square root of 2, didn't we, the last decimal? We did it for the first question. Was it 1.4? All right, so 1.4 would be about right here. So knowing the ones that we already worked on, what is a good approximation without even typing it in? If you typed it in, don't say. What do you think square root of 3 is a good approximation here?
1.65.
Okay, so somewhere here, obviously, right? Anything on either side of this would be bad guesses. We know it has to be in here somewhere. Jonas, why don't you type it in and let us know what it is? Jonas.
I got 1.73.
1.7. Good?
Yeah.
All right, so 1.7, maybe about right here. Square root of 3, and we're going to say that that is about 1.7. So if you were to draw that, like we did these other ones, it would be 1.7 both ways, roughly. That's what the square would look like, kind of like we did over here. 1.7, 1.7 to be a total of 3 squares inside of there. So they overestimated there. All right, we're going to do a couple more practice here. Let's go to the bottom of page 41. Josh, give me a number.
7.
Where do you want the 7 to go?
Let's go on the bottom.
Yep. Evan?
9.
Okay. Give an exact number and decimal approximation. Do both of those.
Is 989?
Don't need a calculator for that one, Josh.
What'd you say?
Don't need a calculator for that one.
Yeah, I know.
Why did you write the answer down then?
Put it on the thing.
Of what?
I don't know. I'm just like thinking.
Oh. So you know the answer. You're just not writing it down because you're thinking.
Yeah.
Interesting. Need more time?
Yes.
There you go.
I got it.
I'm on
I
the 10.
didn't finish the second one yet.
Same.
I haven't started.
Corbin done with the first one?
I don't even know how to do it.
You just plug it into the formula.
I know I.
You did that? What's A? Well, what are the legs? What are the small sides of the triangle?
7.
There's no 7 here.
Oh, that one. I thought you meant the other one.
Oh,
Well, we're going to do both, but
6.
okay. Would it be wrong if I said 8? No. And? The order doesn't matter. So can you square them and add them up for me?
maybe.
Do you know what 6 squared is?
Oh.
Do you know what 8 squared is?
64.
And can you add those up?
10.
So you get 100 equals c squared, and of course to do the opposite of squaring, I'm going to take the square root, and I get 10. Now, do not need a decimal approximation for that one. That one came out nice. Not always going to happen. There's some things called Pythagorean triples that come out perfect. 3, 4, 5 comes out perfect. 6, 8, 10 comes out perfect like this. 5, 12, 13 comes out perfect. And that just means you're not going to get a decimal. This one does not come out perfect, I'm sure, because we just made up numbers.
Yeah.
What's A and B?
49.
7 and 9 are A and B. The order you put them in there doesn't matter. 7 squared.
49.
Jared just keeps yelling 49. 9 squared, Evan.
80 something. 81. 81.
Thanks, Evan.
You're welcome.
Can you add those for me, Autumn?
130.
So my exact answer is the square root of 130. My decimal answer, Colin. Do you agree with that?
Yeah.
And now again, that should make sense because it's a little less than 144, which we said was 12, right? 12 squared was 144. All right. Okay, so this question, number 1 here to start. Now you're going to draw your triangles. And you're going to try to find the longest side. Exact and estimated to the nearest tenth, just like we got done doing. That's question
So is each,
number 1. Yes, each box is 1. All right, next one, you're plotting each number on the number line. Okay, let's add a couple here so I can kind of show you what you want. Add the square root of 25 and the square root of 50. We're going to add those, and I'll show you how to do those too. So we're just going to plot them. What is the square root of 25? 5. So I'm going to put that right here on the x-axis, and I'm going to label it square root of 25. Okay, I don't want you to just type these in a calculator. I want you to use reasoning. So the square root of 50, we don't know that one, but we know the square root of a number very close to that. We know the square root of 49 is, so the square root of 50 is just a little more than 7, right? So just go to a little bit to the right of 7 and put the square root of 50. Okay, so that's what I want you to do to the other numbers there. Just plot them. Question number 3 is going to be like the one we did today. Question 4. We have not talked scientific notation, so let's scratch that one out, and I'll just make you another triangle here.
we love triangles.
For number 4.
Square.
Jonas, number.
7. Why?
No more 7s.
Okay.
Brooks.
10.
10.
Thank you, Brooks. Wait a second.
7.5.
I can't hear you because Josh is talking.
4.
14. Nice.
Thank you, Brett.
14.
14.
All right. 10 and 14 were chosen.
I said 4.
14.
Wow.
Find the longest side. Again, I want exact
5.
and decimal equivalents. Back page.
Review.
Review.
Ew, that's so gross.
Slopes.
We'll take that for last.
All right, so 1 through